This is the coding project that I built back when I had minimal experience on my resume and it was able to get me multiple big tech interviews. It's a simple CRUD application that I built allowing users to search for players for their fantasy Premier League team. There were two main reasons why this coding project was so successful. First of all, it's in something that I'm very passionate about, which is the Premier League and soccer. So in any interview, when I would be asked to talk about this coding project, I could go into immense detail on everything and why I made each decision. Not only that, it's a passion that a lot of people share, so when a recruiter actually had the same passion as me, it was easy to connect with them on a human level. Now, second is by far the most important, it was built in the most in-demand technologies for big tech companies. For backend development, this includes Spring Boot and PostgreSQL. So in today's video, I'm going to break down how you could build this coding project for yourself. We're going to start with a simple CSV file, migrate this over to a PostgreSQL database, then connect this database to a Spring Boot application. This Spring Boot application will function as a REST API, allowing users to make requests to get the data they want out of the database. I actually got this CSV file by building a data scraping project, which is also a great thing on your resume. So if you're interested in that, check out this video first. If not, you could just head over to my GitHub. I'll leave this CSV file in that repository so you guys could just download it and follow along. You should be able to also follow along with your own CSV file as long as it's some sort of database. Now let's get started on the coding project. Before we dive in, let's make sure you have the relevant technologies that we'll be using. First is Postgres. If you don't have this already installed, you could check out this tutorial link here. Now you could use any IDE really here like VS Code, but personally I'm going to use IntelliJ because it's perfect for Java programming. So if you want to follow along with this tutorial line by line, I highly recommend you start with IntelliJ. Okay, so the first thing you're going to want to do is head over to Spring Initializer, which is at this URL start.spring.io. Now we're going to want to set up our coding project. So you're going to select your language, which is Java. We're going to make a Maven project and then do Spring Boot 3.3.1. Now you could go ahead and name the project metadata. So I'm going to do com.pl for Premier League. I'm going to name the artifact Premier-Zone, and the name will be just Premier Zone uppercase. And you could give this a description. It's not necessarily necessary. I'll just write a Spring Boot app for a Premier League fantasy website. And you could just leave this package name. It'll be automatically generated. But be careful, make sure you're selecting the Java version that you have locally. So I'm going to do Java 21. Now you're going to want to go ahead and add dependencies. The first one being Spring Web, which allows us to build web and RESTful. You're going to also want to go ahead and add the Spring Data JPA. And finally, we're going to want to add the PostgreSQL driver since we're going to be working with a Postgres database. Once you're done, go ahead and click generate and it will provide you a zip file with your Spring Boot application. This zip file, just go ahead and double click it and it will give you a folder with the Spring Boot application. Now let's go ahead and open up IntelliJ. Select open and then go ahead and choose the project that you just downloaded. Now before we get started, I just want to troubleshoot something because I know this is going to be a very common source of error. First of all, let's head over to File, Project Structure, and make sure that we're using the correct version of Java. So notice how my IntelliJ defaults to the SDK of 11, meaning Java 11, but we selected Java 21. So we want to go ahead and change that to 21 to match our Spring Boot application and click apply when you're done. Now we want to actually connect to the Postgres database that we built previously before we get started. So go and open Postgres and navigate to the database that you built. In this case, it's Premier League data for me. Start by typing \DT to see all the tables in this database. I was experimenting a little bit so you could see 3 different ones. You'll probably only see the one with the player stats. First, what you want to do is to grant all privileges on this database. So go ahead and write grant all privileges on database. And then the name of your database, in my case, is Premier League _data. To Postgres. And now also do the same thing, but for your own account, which is on database, Premier League _data to Eric Kupcha for me, but this is just going to be your username. If you want to verify that everything is working well up to this point in your database, you could go ahead and do select all from and then your table name. So in my case, it's going to be player_stats. and you'll see that I do in fact have the players loading correctly. Now we want to make sure that this database is actually connected to our Spring Boot application. So go and choose View at the top, then go to Tool Windows, and then go all the way down to Database. This will open up this small little window here. What you want to do is click plus, data source, and then go all the way down to Postgres. Now everything should be set up for you to work perfectly fine, but what you want to do is make sure you select the database that you created. So I initially have it defaulting to Postgres, but you want to go ahead and change it to Premier League _ data. And before you move on, click Test Connection to verify that everything is indeed working well. And make sure you click Apply, do not forget. Finally, go to Source, Main, Resources, and then Application.Properties. Right now, it's just going to be this, but we need to actually fix this to allow the Spring Boot application to connect to the database. Now, you could fill out this properties manually, but if you're lazy like me, you could head over to my GitHub here, and it's already set up. So you see Resources, Application.Properties, and we'll just go ahead and copy all of this over. At this point, we could start by running the application to make sure everything's actually functioning like we want to. So you'll see it's just slowly building now. This should take around 3 to 5 seconds. And there you go. You should get this good connection message here. Started Premier Zone application in 2.58 seconds. So if you go over to localhost 8080 and you refresh, you'll see this white label error page. This is actually good. It's because we didn't finish writing the code yet, but this means you're on the right track. So let's hop into the code. We're going to go to main, Java, and then the package we had previously, and create a new package inside of this, which we'll go ahead and call player. We'll then also go ahead and create a player class, which is going to be our entity class. Entities represent the data model in your application, and they map directly to database tables, or in our case, our Premier League stats table. So what you're going to do is start by writing @entity at the top. And this indicates that the class is actually a JPA entity. This means that the player class will be mapped to a table named player in the database. But since we don't actually have a table named player, we want to go ahead and write this piece of code underneath. @table name is equal to player _ stats. And make sure you actually import this. And there you go. Let's start by writing out all of the fields. This is basically the attributes that every single player will have. So we'll start with private string name, private string nation, private string position. And I apologize, this is going to be a bit long just because we have so many columns in our CSV file. Private integer age, private integer MP, private integer starts. And you want to make sure before I continue that the data type actually lines up with what you have in your CSV file, or there's going to be an error in your code later on. So we're at private double min, private double goals, private double assist, private double penalty kicks, private double yellow cards, private double red cards, private double expected goals, private double expected assist and goals, and finally private string team. Now what you want to do is go ahead and add the @ID annotation on top of our private string name. This annotation specifies that the primary key of the entity is in fact our string name. And this is a unique identifier for all player records in our database. What you want to also add is @column name is equal to name name, which just tells Spring Boot where to find this in our Postgres database. And also actually add unique is equal to true because we want only unique player names. Now be careful, this might not actually be best practice in all use cases. For me, in the Premier League, there are no duplicate player names, so it works perfectly. But in some scenarios, in certain applications, you might have multiple people with the exact same name, so you do not want to be using this as your primary key all the time. Now, if you're in IntelliJ, let's take advantage of the built-in generate function here. If you're not, I'll slow down the code so you could actually just go ahead and type it out manually. I know it's a pain, but what can you do? First, we'll generate the constructors, which are used to initialize objects. There are two types of constructors, a default, which is a no argument constructor, and a parameterized constructor. The default constructor is a no argument constructor that allows you to create a player object without setting any initial values for the fields. Now, a parameterized constructor allows you to initialize a player object with specific values. For example, we could do a constructor with all of the values by clicking all of them. As you can see, the people have to type this out manually. Let me just go through this slowly. It has every single field that we previously defined as a parameter, and then it just goes ahead and initializes them. And you could also just create a constructor with a specific variable. For example, if you want to be able to create a player by just their name, you could do that as well. Next, we're going to go ahead and create our getters and setters. These methods allow access and modifications of the fields. For example, a get ID will go ahead and return the player's ID, and you could have a set ID, which will set a new ID. Or in our case, we have get name, which goes and retrieves the name of our player, or you could set the name, which you could then use to change the name of the player. Now we can move on to creating the repository. Inside the player package, go ahead and create a new Java class, but make it an interface, and we're going to call it player repository. At repository at the top indicates that the interface is a Spring data repository. Now you also want to write extends JPA repository and then player and string. This extends the JPA repository interface, which provides CRUD operations, meaning create, read, update, and delete for the player entity. The parameters, so player specifies the entity type, and the type of its primary key is string. Next, let's write two custom methods. First, we're going to do void delete by name, and then string player name. This just finds a player in the repository by their name and then deletes it. Now what we also want is this optional player find by name string name, because this will allow us to find any player by their name in our repository. And the use of optional is to handle cases where the player might not actually be found in the repository. Moving on, we have the service class. The service layer in a Spring Boot application contains the business logic, and it sits between the controller, which I'll touch on in a little bit, and the repository to interact with the database. In our case, we're going to build a player service class, which encapsulates the business logic for managing players. It's going to leverage the player repository to perform these CRUD operations on the player entity. So go ahead and create a player service class in our package. At the top, you want to write @component. And @component is a Spring annotation that marks a Java class as a component. By doing this, you're telling Spring that this class should be managed by the Spring container. This means that Spring will create an instance of this class and then manage its lifecycle. Let's go ahead and create a field to store our repository. So do private final player repository, and then player repository. What we want to do is actually use @autowired to inject this player repository bean into the service, which will enable it to interact with the database. So let's just go ahead and write public player service as a constructor, which takes in the player repository, and just set this dot player repository is equal to the passed in player repository. Perfect. Now let's move on to writing the methods, which is what actually acts like the business logic. For our application, we'll predominantly focus on the getting functionality for different parameters. So first we could write this function get players, so public list, because we want to return a list of the player type, get players. This is just going to retrieve all of the players from the database. So player repository dot find all. And this find all simply returns a list of every single player. Now next what we want to do is write a get functionality to get players from a specific team. Let's do public list player get players from team string team name, and then return player repository dot find all dot stream, and we're going to filter the player team name dot equals player dot get team, and also dot collect collectors dot to list. And this is going to return the players specifically from a team. For example, if I wanted to get all the players from Arsenal, it'll return all of the players from Arsenal. Now let's write a get functionality to get specific players by their name, because you might want to use this. So public list player, in case people search for only their first name, for example, like a Bruno might return multiple different players. So public list player get players by name, string search text. So this is perfect for like a search bar functionality. Return player repository dot find all dot stream dot filter player and player dot get name dot to lowercase, just in case there's some uppercase mismatching. Dot contains our search text dot to lowercase. Now, if you want to have a search functionality that will only ever return if the name's exact, you don't need to do dot contains, you could do dot equals. But I prefer this dot contains. I just think the search functionality is better this way. So collectors dot to list. Don't forget the semicolon at the end. And now let's go ahead and write another get functionality for public list player get players by position, because say in a fantasy Premier League team, you might want to look for specific positions like a defender or a goalkeeper. Now you want to do return player repository dot find all dot stream dot filter player dot get position dot to lowercase dot contains search text dot to lowercase, and again we're going to do dot collect collectors dot to list, and again we want to have functionality to be able to get players by their nation. because this is another useful thing for fantasy teams. For example, if you want to get all English players, so get players by nation, string, search, text. Now you don't need to have all of these get functionalities. This is just because in my front end, I actually wanted different tabs to allow people to interact with different searches, but you really only need 1 or 2 gets. I'm just going to show you how I built out my full application by doing this. We'll do return player repository dot find all dot stream dot filter player dot get name get nation, sorry, player dot get nation dot to lowercase dot contains search text dot to lowercase, and then we're going to do dot collect dot collectors to list. And then our final get functionality is going to be to get players by team and position, and this is honestly the most useful in a fantasy Premier League app. So do public list player get players by team and position, string team, string position. We do return player repository dot find all dot stream dot filter player team dot equals player dot get team and position dot equals player dot get position, and finally again the dot collectors dot to list. There seems to be an error. Player, oh my bad, player here should be player team player dot. Okay, there's a small error here actually. So you want to do is close the bracket here. That's my bad. And position dot equals player dot get position. Remove this, and perfect. There you go. Now let's move on to some other functionality. First, you want to have this functionality if someone wants to add a player to your database. You do public player add player repository dot save player, and this is just simply saving this new player to the repository. It's relatively straightforward. And return the player just so you can see what was saved. Now we want to have some functionality to actually update a player because obviously stats change, players move teams, etc. So let's do public update player, updated player, optional player, existing player is equal to the player repository, and then find them by their name. Get the updated player dot get their name. And now this is where you want to check that the player first is present. So let's do if existing player dot is present, meaning they're in the database already. And we get the player that you want to update. Player to update is equal to the existing player dot get. And then we're going to start using the setters here. So player dot to update dot set name, updated player dot get name. So this takes the name from the updated player and sets the value of the old player to this new name. And we're going to go ahead and repeat this process for the team, position, and nation. So I'm just going to go ahead and copy over the code for time's sake. but you guys could write this all out yourself. It's the exact same thing, just set team, set position, set nation. And after all of this, you want to actually make sure in your repository you're saving this new player, and then optionally you could return the player to update. I like to do this so you could see whether or not the player was correctly updated, and return null if nothing was actually found in the database. And now finally, we want to have some functionality to delete a player. Since this is a Premier League application, certain players move teams out of the league or they retire, so you no longer want to have them in the database. So let's have delete public void delete player string player name player repository dot delete by name, and then player name. And that's it for the service controller. So now what we want to do actually before is to add an @transactional above this, because this makes sure that the operation is part of a transaction, meaning it will maintain the data integrity during this delete operation. But besides that, this is the entirety of the service class. You don't need all of these get operations. Feel free to skip them. The ones I really think are necessary is the get players, a get players by name, and maybe a get players by team and position. So finally, let's move on to the controller. The controller layer in a Spring Boot application handles incoming HTTP requests, delegates them to the service layer, and then returns the appropriate response. So what you're going to want to do is go to this player package and create a player controller class. So player controller. First, you're going to write @rest controller, because this marks the class as a Spring MVC controller where every method returns a domain object instead of a view. And this is the shorthand for @controller and @response body combined. And you'll see why this is important in a second. What you also want to do is write @request mapping, and then path for us is going to be API/v1/player, but feel free to change this to whatever you have or whatever you want the URL to be. So you don't need all of this API v1/player. It could be just players or anything you want. It's not that necessarily, because in the front end, you're not going to see this. Now let's start by creating a field to store the player service. So final player service, and we're going to use the @autowired again to inject the player service bean @autowired, which allows the controller to delegate the business logic back to the service layer. So @autowired public. So this is just a constructor for the player controller, which takes in the player service. This dot player service is equal to player service. There you go. Now what we want to do is actually start figuring out the mapping requests for HTTP requests. So first of all, we could do @getMapping to handle all GET requests. @getMapping. So what we're going to start by doing is public list players, because the get will return a list of players as we saw before. So let me actually just go ahead and import this. So get players. And what we want to pass is different request parameters. So you have @request param, and these are not required, so make sure you do required equals false. String team, so you can search by teams. I'm just going to duplicate this. So the different things we want is string team, string name, string position, and then string nation. These are all the different parameters you could use to get players from our database. Let's just remove this. Now we want to write the logic, which is the method is going to return a different player list based on the presence of these query parameters. So if no parameters are provided, it's just going to return all the players. So we'll go ahead and start by writing if team does not equal null and position does not equal null. This is for searching. Oh, does not equal null. What you're going to want to do is return the player service, and you're getting the players by their position and by team and position here. So then just pass in team position, and that's it. And you're just going to keep doing this for every single different possibility of inputs. So say you want to search by just team. So if the team's not null, meaning it was present in the request parameter, you do return player service dot get players from team and then the team name. Or if you want to do a search for names, so if the name parameter is present, we're going to want to do return player service dot get players by name and then pass in the name parameter. Now else if the position is not null, meaning you in fact wanted to search for just positions like defender, for example, you do return player service dot get players by position and pass in this position parameter. And now finally, we actually had the nation functionality. So if nation is present, return player service dot get players by nation and then pass in the nation parameter. And finally, we want to have this else. This is if no parameters were passed in at all, meaning we want to actually get every single player in our database. So we just do get players. That's everything for the get mapping. So what we're going to do is move on to the at post mapping. At post mapping. And this handles HTTP post requests to add a new player to our database. So the first thing you're going to want to do is write public response entity, and you're going to want to return a player, then add player, and the request body in this case is going to be the player that you want to add to the database. So let's see, player created player is equal to player service dot add player and then the player. So this is calling our service class to go ahead and try to add this player that was passed in the request body to our repository, and then it's going to return the response entity for created player and HTTP status dot created. This means that it's going to return the created player with an HTTP status of 201 created if this was fully successful. We're going to do something very similar for the at put mapping. And put mapping handles HTTP put requests to update an existing player in the database. So again, what you want to do is start by writing public response entity and the player and update player, and we want to pass in again as a request body the player that we're updating, And just like with the add player, what we're gonna do is get result player is equal to player service dot update player and updated up oh, up player. Sorry, I had a little brain freeze there for a second. And now remember in our player service class, when we went to actually update this player, we had a potential of returning null. And this will happen whenever the player is not already present in the database, because you can't update a player that doesn't already exist. So what you want to do is if result player is not null, return new response entity, and then result player and http status dot okay, and this is gonna happen if the update was indeed successful, and otherwise you do return new response entity with the http status dot not found to indicate that the player was not found in the repository. Finally, what we're going to do is a delete mapping, which handles all HTTP delete requests to delete a player specifically by their name. So let's do @delete mapping, and since it's specific to a name, what we're going to do is @ and then the player name in squiggly brackets. And this is going to be basically the name of the player that you're deleting. So let's go ahead and write public response entity string delete player is the name of this method. And we're going to take a path variable string player name. And this path variable is this player name that gets passed in the delete mapping. So what we want to do is simply call the player service and try to delete the player from player name. And then you just return a response entity if the player was deleted successfully. And then http status dot okay. All right, awesome. So that is everything that you need for writing the code for this basic CRUD application. So you can actually go ahead and rerun the application at the top. Click stop and rerun. It's going to take another 5 seconds or so to terminate the process and rerun it, so you can see it's actually working. And everything worked perfectly fine when you see this at the bottom info. So if we go back over to our localhost 8080, at first it's going to show this white label error page, but that does not mean that something's wrong. It's actually because we changed the mapping to be /API/v1/player, if you remember. So what you're going to want to do is go ahead and type in /API/v1/player in the URL. And when you search, you click pretty print, you'll see these are every single player in our database. So that means the get players worked properly. If you want to test other functionality, for example, getting a player by their name, you could do name equals, for example, Diego Dello. There's his name. Or if you want to do position is defender, and this is every single defender in the Premier League. And this just shows you that the application was fully functional. So that's the end of this tutorial. You should now have a fully functional backend coding project. If you want to look into next steps, maybe build a React.js application to connect this to your front end, because building a full stack application is crazy good on your resume. If you want to focus more on the backend development side, maybe look into JWT authentication so only authorized requests can be made. You could also look into the data scraping side and make sure there's some sort of constant polling so the data is consistently updated and your database is always up to date. For hosting, I highly recommend you guys check out Supabase for your database, and then Heroku if you're on the GitHub Pro, or Render. If you liked this tutorial and found it helpful, please just make sure to leave a like and subscribe. And if you want more one-on-one mentorship on how to build coding projects that will get you hired, or if you just want resume reviews or a bunch of other coding resources, I highly recommend you guys check out my community. I'll leave this in the description below. See you in the next one.